All right, so let's practice. The first question, y is equal to the tangent of x to the fourth. By the way, for each of these practice questions, you may want to just pause it, after I pose the question, and then try to work it out. And after you think you are done, you may want to look at the rest of the video. All right, so at this point, you can pause this and then come back when you have solved the problem. All right, so what is the derivative, right? Remember, this is a tangent of the blob. So the answer, the derivative is going to be the secant of the blob, which is x to the fourth. And then you multiply this by the derivative of the inside, 4x cubed. And so this will be 4x cubed times secant square of x to the fourth. Get that? All right, great. The second question, y is equal to 2x to the third minus x plus 1 to the fourth power. Okay, so pause the video and see if you can find the answer. All right, the answer, you have something, by the way, it's really important for you to be able to identify what's inside and what's outside, right? The outside function, remember, is the last thing you do, which in this case is something to the fourth, all right? So blob to the fourth, what is the derivative of blob to the fourth? The answer, 4 times the blob to the third. And inside of the parentheses, nothing changes. Multiply this by the derivative of the inside function, which is 6x squared minus 1. And here you can't really simplify. I mean, you can, but it's going to be quite messy, so you don't have to. All right, simple, right? I think it's something that you can easily learn. All right, let's go to the next one. Y is equal to sine 3x. Now, this is a sort of a strange notation, but it is traditional and it is often used, and it means the same thing to anybody who has studied mathematics. This actually means sine x to the third power, right? For some reason, somebody decided to put the exponent in the middle right before that, which is a little confusing because it seems like you do sine of x, and then you take the sine of that x, the sine of x, and then, this sounds like the sine of the sine of the sine of x, but that's not what it means. This is sine of x, evaluate that, and cube it. All right, so the outside function is actually the cubing function, and the inside is the sine function. All right, try to figure this out and come back when you think you got the answer. The answer, the derivative is, remember, 3 times the blob square. And the blob is sine of x. Multiply this by the derivative of the inside function, the cosine of x. That's it. All right. Of course, you may want to write this, in a more canonical way. That's sine square of x times cosine of x. Same thing. Okay. No problem here. All right, let's go to the fourth one. How about y is cosine of 3x to the fourth? Oh, and by the way, this is okay, but I just want to make sure that you understand it's not cosine of 3 times x to the fourth. It's cosine of this quantity, right? So to avoid ambiguity, I recommend that you put parentheses in here. Okay, what is the inside function? It is 3x to the fourth, because that's the first thing you do to x. You take the fourth power and multiply that by 3. And then you take the cosine of that result. So the cosine function is the outside function. Pause and come back when you think you got the answer. Y prime is negative sine of the blob, the cloud, times the derivative of the cloud, which is 12x third or cubed in this. Again, traditionally, we try to write the polynomial part first. So negative 12x to the third times the sine of 3x to the fourth. And that is your answer. Okay. All right. So let's see if we can do one more. All right. So number 5 is maybe it's too simple. Okay. Sine of 2x. So what's the derivative? Okay, the sine of 2x is, well, the derivative of the sine of 2x. Remember, this is like, sine of 2x, right? Where the doubling part is the inside function. So the answer is going to be cosine of 2x times the derivative of the inside function, which is 2. Okay, I'm going to multiply this by 2 in front. So the answer is 2 times cosine of 2x. Okay, and of course, if you have the second derivative, it's going to have -4 in front of the cosine of 2x and so on. All right, so this is it. Now, the reason I wanted to show you this is because, remember, you can write the sine of 2x in another way. It's the double angle, so you can use the double angle formula to write y as what? 2 sine x cosine x. Do you agree that this is equal to sine of 2x? You should, because that's the double angle formula for the sine function. And now this does not require the chain rule. Why not? Well, because there is no composition here. It's basically 2 sine x times cosine of x. So let's apply the product rule, assuming that the first one is 2 sine of x and the second function is the cosine of x. Using the product rule, you get the derivative of the first, that would be 2 cosine of x, times the second, plus first times the derivative of the second, which is negative sine of x. What is that? It's 2 cosine square x minus 2 sine square x, right? Wait a minute, that doesn't look the same as what I got here, or is it? 2 times cosine square x minus sine square x if you factor out the 2. And you may have noticed this is one of those 3 double angle formulas for the cosine function. So it is indeed 2 times cosine of 2x. Ah, that's the same. Great, right? Again, it is very pleasant when you get the answer that you really wanted. All right. All right. Any other things we have to do? Yeah, I promised I'm going to do a little more complicated one. So what happens with this question? Y is equal to sine square of 2x to the 5th. Now you could, of course, just in order to emphasize the fact that this is a composition function, let's go ahead and write this as sine of 2x to the 5th raised to the 3rd power. Oh, sorry, the square power, right? Second power. Do you see at least 3 functions being composed together? Okay. Actually, I see 4. Right? Try to identify this. This is a great exercise for you. I want you to look at this and identify the 4 things you do to x in order to evaluate this. And those 4 things have to be done in a certain sequence because this is a composition, right? It's like when you get up in the morning, what are the 4 things you do? And you do them in order because it would make sense, right? For instance, you may wash your face and then you wipe your face, not the other way around. Okay, so what do you do with x when I give you x to evaluate this function y? Here's the first thing you do. Number 1, you take x is given, you take it to the 5th power, right? I mean, if let's say if I ask you to evaluate this at, x is equal to 2, but the first thing you do is to take that x and raise it to the 5th power. And then you double it, multiply by 2. Now you have this part. And then you take the sine of it. Take the sine function. SINE is how you spell sine, except in mathematics, you just write SIN. And then finally, you square, right? So remember, you are doing 4 things in this order in order to evaluate this. So this really is the function consisting of at least 4 compositions. You can also think of this as a composition of 3 functions, if you like. The most inside function, the innermost function is 2x to the 5th. Okay, yeah, let's go ahead and write this. Oops, come on, erase it. All right. Let's try to write this as f of g of h of x, which is f of g of h of x, like that. The h is the first thing you do. So let's say h is equal to 2x to the fifth. Okay. Now taking the sine function, that would be the g, and that's just the sine of x. Now when you compose these, you get sine of 2x to the fifth. And then the last one, f of x, the outermost function, is simply the square function. I know this is confusing because for each I'm using x as the independent variable, but if you compose these correctly in this order, you are going to get exactly this expression, right? All right, so now let's try to take the derivative. The first cloud you see, I mean this is the what is that? That's the blob, okay? Because the outside function is the square function. So that becomes 2 times this big blob raised to the first power. Of course, you don't need to have that, right? And then you just go ahead and fill this as sine of 2x to the fifth, okay, to the first power. And then you focus on the derivative of the inside function, which was the derivative of this. But that itself is the composition of two functions. So that becomes cosine of this innermost blob. Okay, that's this. That's the h is the innermost blob or the innermost function. And so it's a cosine of 2x to the fifth. And now we get to look into the innermost function and differentiate this guy. So that's 2 times 5, 10 x to the fourth, right? And that itself, the whole product is the solution to this differentiation question. Let's summarize this or combine this, the like terms, well, combine this, simplify this. 20 x to the fourth, sine of 2x fifth times the cosine of 2x to the fifth. And just to avoid ambiguity, I would use parentheses. All right, so that's the answer to that question. It's not, I mean, it looks complicated and messy, but it's really not that hard, okay? And I think you can all appreciate that. Now, remember, the chain rule is something that you will likely use most of the time. Every time you see an assignment, you will probably use this several times, repeatedly. So make sure you understand this. It's not a hard thing. It's not a difficult skill to gain. So make sure you understand this and master this before you go to the next section, which is 3.7. All right, that's it for this section. I will see you later.